right, guys, so 472. We're going to look at problem number 40 from 4.7 or 7.42. Now, when we're simplifying these rational expressions, we figure out what we need to multiply the whole thing by on top and bottom to get the fractions to simplify out. Now, on top, the only fraction we have is the 2 over x, so we're going to multiply it by x. On bottom, the only fraction we have is the x over 5, so we're going to need to multiply it by 5. And we do this multiplication on top. 5x times 15. 5 times 15 is going to be 75, and we have our x. Minus, and then we'd have 2 times 5x over x. And we could multiply that 2 and 5, which would give us 10x. On bottom, 5x times x is going to be 5x squared over 5 plus 5x times 4, 20x. $75x is still going to be 75x minus our x and x, because it is multiplied on top, but simplified just give us 10. On bottom, 5 and 5 would cancel, giving us x squared plus 20x. And I think that's where you got for sure, yes? Yep. Now at this point here, 5 is the greatest common factor on top, because that would give us 15x minus 2. On bottom, we have a greatest common factor of x, giving us x times x plus 20. Now, both did have factors we could simplify it, but even after doing that, there's nothing to simplify on top and bottom. So I would still factor to this point. I would still get it here, but this would be the final answer. Even though nothing does simplify on top and bottom, it's just, this is the answer. Questions? Any other questions? Take that again. Yes. 42. So we'll look at 42 as well. 16 over x minus 2, all over 4 over x plus 1, plus 6 over x. Now we need to figure out what we need to multiply through to get the denominators to cancel. On top, the denominator is x minus 2. So we know we'll need it once because it only shows up once there. If it shows up once in the denominators, we still only need it once. However, it doesn't. On bottom, we have the x plus 1. So we'll need it, and then we'll also need an x. Because since all three denominators are actually distinct and unique, we ended up having to take all three. Now on top, we're going to multiply the 16 by x times x plus 1 times x minus 2 all over x minus 2. On bottom, the first fraction is going to be 4 times x plus 1 times x minus 2 all over x plus 1 plus, then we'll have 6 times x plus 1 times x minus 2 all over x. Now on top, the x minus 2 and x minus 2 will cancel. On bottom, the x plus 1 here, and here the x and x. So what we have left in the numerator is 16x times x plus 1. That's the only thing left on top. The denominator, we have 4x times x minus 2 plus 6 times x plus 1 times x minus 2. And we need to simplify that denominator there. Now, something that is interesting with this here is because x minus 2 is in common with both, we could actually factor it out and make simplifying a little bit easier. What we can do is multiply these out. So 4 times x is going to be 4x squared. 4 times negative 2 is going to be negative 8x. Here we're going to have to distribute out, which is going to give us x squared minus 2x plus x minus 2. Now we would combine like terms. Our x negative 2x plus x would combine to give us like terms. And then we would have to distribute the 6. Which would give us 6x squared minus 6x minus 12. Now 4x squared and 6x squared would give us 10x squared. Our negative 8x and negative 6x would get us here. Now there is a greatest common factor of 2 that we can factor out. Now outside, the 16 over 2, the 16 on top would simplify to 8 because I'm going to do 2 simplifying in one step. Because 16 over 2, 16 divided by 2 is 8. We're good there. And this denominator will factor, because since our 6 is negative, our signs are opposite. We'd have 5x and x, 3 and 2. And that would be the final answer. I know I went a little quick with that, but x plus 1 and x minus 2, where we time. Yes, when we do that multiplication, it feels like we need to multiply like this, but really this whole top piece is being multiplied by the whole numerator. And when we do that multiplication, it's only multiplied with the tops of the fractions, not the bottoms. Mm-hmm. Yes, and that whole multiplying by top, this instinctual thing to do top and bottom, that's why when we did it the first time, I wrote out specifically those being set next to each other. Mm-hmm. Yep. Mm-hmm. Yeah, no, that's why. Sound good? Or that makes more sense? Awesome. You're welcome. If you have any other questions, let me know. Because what we're doing today is we're finishing up the note sheet from yesterday, solving. So our 752, or 751. And we look at this here, and we multiply. We want to multiply by an expression, multiply the whole thing by an expression that makes the denominators simplify out. And we also want to make sure that the denominators, the bottoms of these fractions, are factored as far as possible so we don't add any extra factors. Now our first expression, negative 4 over x plus 3, the x plus 3 is factored as far as it goes. Our other fraction, 5 over x minus 3, the x minus 3 is simplified as it gets. So we're good there. Now our restrictions are any value of x that's going to make the denominator be 0. Well, x plus 3, that's going to be negative 3. And if we solved it here, minus 3 tells me that if x is negative 3, the denominator be 0. Can't have that. With our x minus 3, we would add 3, telling me that if x is positive 3, the denominator would be 0. That does not work. Neither one of these values would work. They would be our restrictions. Questions on restrictions before we look at solving? Now, when solving and multiplying through, we can look at least common denominator, figure out what that whole expression is, multiply all the way through, and move on from there. Or we can take it one piece at a time. As if I look at the left side, I know I'm going to need an x plus 3. Because if we multiply that left fraction by x plus 3, that x plus 3 we're multiplying it by, and its denominator would simplify out. We wouldn't have a fraction there. Then I would look at the other fractions. The one on the right, the x plus 3 is not going to cancel it out. I actually need an x minus 3, so I multiply the whole thing by x minus 3. We take it term at a time. Because x minus 3 over the x minus 3 would cancel. Do we have any denominators left? Now all the denominators have simplified. And what that leaves us with on the right-hand side is negative 4 times x minus 3 is equal to 5 times x plus 3. So we take it one of those denominators at a time, multiply through to get it to simplify, and go from there. Now at this point here, we just need to solve. So on the left-hand side, I would distribute that negative 4 to both terms. Negative 4 times x is negative 4x. Negative 4 times negative 3. The negative and negative would make a positive. 4 times 3 is 12. On the right-hand side, we'll distribute that 5. 5 times x would be 5x. 5 times 3 is 15. Now where we go from here, we could add 4x to both sides. We could subtract 5x from both sides. Subtract 12 from both sides, subtract 15. Does not make a difference. I'm going to add 4x to both sides. Because negative 4x plus 4x is going to be 0, leaving us with 12 on the left-hand side. 5x plus 4x, 5 plus 4 is going to be 9, so we have 9x. And we still have our 15. Got to move the 15 over to the other side. 12 minus 15 would be negative 3. Equals 9x, because our 15 minus 15 would be 0. And last but not least, we would divide both sides by 9. 9x divided by 9 would be x. 3 over 9. Negative 3 over 9 is negative 1/3. That's our final answer, and we're done. And because it's not one of our restrictions, we know it is one of our solutions. Questions on this here? And again, especially on the ACT, a multiple choice test, if we know what the restrictions are, we know that those values cannot show up as an answer choice. So we can remove those from the possible answer choices, less that can give us a better chance of guessing or figuring out what it is. Questions on this here? Be ready for the next one. One over 2x plus 5 equals x over 11 plus 8. I will tell you here, if we set the two denominators equal to 0 and solved, our two restrictions are going to be negative 5 halves and negative 8 elevenths, which is not going to be an answer choice. So neither one of these values of x is going to show up. But looking at this problem here, what do we need to multiply through by first? Because we're multiplying to do what? We're multiplying through to get the denominators to simplify, yes? So what can we multiply the left-hand side by to get that denominator to simplify? Because its denominator is 2x plus 5, yes? So if I multiply that left-hand side by 2x plus 5, we'd have what? 2x plus 5 on top and 2x plus 5 on bottom. Which means that they would cancel. But if we do it to one side, we've got to do it to the other. On the right-hand side, that 2x plus 5 and 11x plus 8 don't simplify because they're not the same. So what do we need to multiply also? Because 11x plus 8, now on the right-hand side, when we multiply it by everything, would cancel. But, yeah. Yes. Questions on how we figured out what to multiply everything by? So let's see what's left. On the left-hand side, we have the 11x plus 8 being multiplied with 1, which is just going to be our 11x plus 8. On the right, we have the x and 2x plus 5 being multiplied together. Now the left-hand side is kind of nice. It's just going to be 11x plus 8, because that's all that's left. On the right-hand side, we're going to have to distribute this x. X times 2x is going to be 2x squared. X times 5 is 5x. Now this is a little different than all the ones we've done up to this point because we actually have an x squared term. Anytime we get these x squared, x cubed, we get a variable to a power bigger than 1, we need to get this equation equal to 0. So what we're going to do is move everything over to the same side. So I will subtract 11x first. Telling me 8 is equal to x squared, 2x squared. 5x minus 11x, 5 minus 11, it's going to be negative 6. Subtract 8 from both sides, telling me 0 is equal to 2x squared minus 6x minus 8. Questions on how we got it equal to 0? So we have a quadratic. Quadratics can be solved by factoring, graphing, completing the square quadratic formula. We have several options. Which way do we want to solve it? If we solve this by factoring, the first thing we want to do is see if there's a greatest common factor. And there is a greatest common factor of 2. Because 2, 6, and 8 are all divisible by 2. So it tells us that we have 2 times x squared minus 3x minus 4. Now, with solving, that greatest common factor doesn't really mean a whole lot. It is there, it is part of our solution. But according to the zero product property, it states that whenever we have 2 or more things multiply together that equals 0, one of them must be 0. Since our greatest common factor is just 2, there's no way we can make that 2 be 0. The only thing that can be 0 is the quadratic part. So yes, the 2 is there, but in the end, it's not going to impact our answer. X squared minus 3x minus 4 will factor. Third term's negative, so our signs are positive and negative. Factors of x squared are x and x. Now our factors of 4 are 1 and 4 or 2 and 2. Which one do we want to try first? 1 and 4. Interestingly enough, if it is 2 and 2, since we have the plus and minus, it's a difference of perfect squares. Those would be the factors x plus 2, x minus 2. The middle term would be 0. So 1 and 4, x times negative 4 is negative 4x. 1 times x is positive x, giving us negative 3x. And again, I'm just doing that to make sure I got the right factors. Just checking it. So x2 times x plus 1 times x minus 4 is the factored form of our 2x squared minus 6x minus 8. Questions on how we got to this? So it's factored form. We have 2 or more things multiplied together that equal 0. So one of them must be 0. So what that means is either x plus 1 is 0 or x minus 4 is 0. Since our 2 does not have a variable with it, there is no way for me to make it be 0 by putting in a value of x. So we don't need it for this part. Well, x plus 1 equals 0, we can subtract 1, telling us that x is equal to negative 1. And with our x minus 4, we would add 4, telling us x is equal to 4. So with these rational equations, we can have 2 solutions. It is possible to have 2. It's possible to have multiple solutions with rational equations. We won't always have them, but it is possible to have more than one. And since neither one of these equations is our restriction, both of these will work. We can plug both of them in and they will give us a true statement. Questions on this here? We ready for the next one? So we have 5 over x plus 7/4 equals negative 9 over x. So this is the first one where we've had more than 2 fractions. We have more than 2 statements. But again, the same goal is still here. We want to simplify those denominators so we don't have to work with fractions. We don't have to mess with fractions. So we can look at the one on the right. Negative 9 over x. What would we need to multiply it by to get that denominator to simplify? X, yes? Because if I multiply this by x, we would get what? Negative 9x over x. Because it is multiplied, the x and x would cancel. But that means I also have to multiply everything else in that equation by x. Because it's up to this point, it seems like we just multiplied the 2 things both sides. We're just multiplying everything. So since we multiplied the negative 9 over x by x, we also have to multiply 7/4 by x and 5 over x by x. And we can go through and check and see if anything else simplifies. 7/4, well, 7x over 4. That x and 4 will not cancel. How about the 5 over x? the x's cancel. So I go through and take it one term at a time. This is one way we can do it. So we're not having to try to think of the whole thing all at once. Multiply through by x. Two of the fractions, the x is simplified, and we're good there. Is there anything else on the bottoms of the fractions that didn't simplify? The 4, yes? And to get that 4 to simplify, well, I'm going to need to multiply that middle term by 4, yes? Because if I have that multiplication of 4 in the middle, it would simplify, yes? But that also means I need to multiply everything else by 4 too. So really the least common denominator that we needed was 4x. We got there by taking piece by piece, what do I need for each one to simplify? Questions on how we figured out to multiply by 4x? Questions? Or just trouble seeing from there?
Yeah.
Because if we look at what's left, in the first fraction we have 5 times 4, which is 20. The middle one we have 7x. And in the last one, negative 9 times 4 is negative 36. Now to get x by itself, what can we do? We can minus 20 from both sides. Because our 20 minus 20 would be 0. Leaving us with 7x is equal to negative 56. Negative 36 minus 20 would be negative 56. And last but not least, we would divide by 7, telling us x is equal to negative 7. So even though we did have 3 terms, we could go through the process. We didn't specifically do it. Least common denominator, look at all 3, figure out, factor down, see what the least common denominator is, multiply through. Or we can look at each term and see what's going to cause it to simplify and multiply through by it. And take it one piece at a time. Questions on this here? How many denominators does this equation have? Okay, we could say 3, but the 1's denominator is just 1. Doesn't matter, because we're just trying to get those fractions simplified. We need to find out what we need to multiply through to get the fractions to go away. Well, we can look at the 3 over x first. What do I need to multiply it by to get that fraction to go away? X. If I do it to 1, we've got to do it to all of them. And the nice thing is that x over x, because it is product on top, single term on bottom, they are gone. I'll check the others, because we do have in the middle x minus 5, well, the x and x minus 5 aren't going to cancel. 1 doesn't have a denominator, so we're good there. What are we missing? Well, x minus 5. Because we need that x minus 5 for the middle term for those two to cancel. And again, we haven't needed it for this one or most of all the ones here. If the denominators can factor, we need to factor. Questions on this here before we move on? With the 1, we have 1 times x, which is just x, times x minus 5. So we'll have x times x minus 5. Minus 8 times x is equal to 3 times x minus 5. Awesome. Now we do need to simplify and see what we have. Now on the left-hand side, our x times x is going to be x squared. X times negative 5 is negative 5x minus 8x. 3 times x is 3x. 3 times negative 5 is negative 15. Since we do have an x squared term, we are going to have to get this equation equal to 0. Now, before I start moving anything, I do want to combine like terms. I want to combine that negative 5x and negative 8x. Because we want to simplify combine like terms on either side before we start moving things across, just so we don't have as many terms to work with. Now, the direction I move my terms, which side we move them all to, really doesn't make a big difference. I try to keep the x squared term, the variable with the biggest exponent, positive, if at all possible. So I'm going to subtract 3x first. Negative 13x minus 3x will be negative 16x. 3x minus 3x will cancel. Then we're going to add 15 to both sides. Getting us to x squared minus 16x plus 15. Questions on this so far? Scroll back up. Far enough? Now, solving from here, we're trying to find out what values of x will make x squared minus 16x plus 15 be 0. One thing of note, if we're going to have real solutions, and they're going to be rational, if we know we're going to have a fraction, a has to be something other than 1. If we're going to get 2/3, 7/8, actually get a fraction, we would have a value in front of a, because that's where most of those come into play. But what is the value of a here? 1. The number in front of x squared is 1, so that tells me if I have real solutions that are not irrational, they're going to be nice integer numbers. They're going to be non-decimal numbers. Which tells us that what? We should be able to graph it. So if I wanted to graph this, we'd have x squared minus 16x plus 15. We can grab the graphing calculator, hit y equals. We can type it in and hit graph. And we do see that it crosses at one nice point. And one of the values of x that makes this function equal 0 is 1. And the other is 15. So according to the graphing calculator and graphing it, it tells us that x is equal to 1 and x is equal to 15. And those are our two solutions. Those are the two values of x that will make this function equal 0. Questions on this here? That might be interesting why I need to go to positive 15 or go to 15. What are the factors of 15? 1 and 15 are 3 and 5. So there's a good chance if we had gotten positive 3 as a factor, or it told us on the graph that x equals, well, y equals 0 when x is 3. When we have the x value of 3, the y value is 0. Probably the other solution we should look for is 5, since 1 was 1 and 15. Because this factors, since the third term is positive, our signs are the same and match the sign of the middle term. Factors of x squared are x and x. Because if we went about factoring it, we get to the same exact spot. Questions on this here? That's the exact same too. Questions on what we've done with these. Questions on these solving. Yeah. Any questions over any of what we've done here? I know we have two more. They are the exact same as what we just did. On Monday, we will be going through more of these. We are doing more solving, going through these steps and seeing this here. Because when we look at this here, again, factoring the denominators is huge. Because if we don't factor it and there's an extra factor listed that we add into it, it will give us another solution. It will give us another value of x that would make the function be 0 in solving. But any value of x that we add is going to be an extraneous solution. It's going to be a value of x that does not work. Either one of these that we want to look at before we finish today. Six through 9, 12 through 19, 8 problems. Six through 9 is our one term on either side. So we just multiply, cross multiply to get those. 19, 20, 21, 22. We multiply through to simplify there. I will tell you this here, for number 20, 6x is all you need. You can multiply by 3x and 6. It will give you the answer. It's just going to have a division, extra division you don't need.